Good evening. My name is Samuel Hui, and tonight I will be going over how to do Part C of Question 2 in the first exam, as well as going over what I did wrong the first time I answered this question. So, for some context of the problem, we are being told that two kids are playing catch with a ball across a road. The two kids' names are P and Q. To be honest, I have no idea why their kids are named that way, but let's just continue with the problem. And they are located in this intersection as so. Additionally, we are being told that a car called car B is moving directly south along the road at a certain constant velocity relative to the ground. And what this problem is asking for is the problem wants us to find the cosine of the angle between two velocity vectors of the ball relative to car B in two scenarios. One, when P passes it to Q, and in the other, when Q is passing it to P. So, to start this problem, we realize that the cosine of the angle between two vectors can be found in a dot product formula that we learned in class, which follows that the dot product of two vectors is equivalent to the product of, let me just erase that, it's supposed to be 2. It's that the dot product of two vectors is equal to the product of the magnitude of each of the vectors, as well as the cosine of the angle between these two vectors. We also know another way to find the dot product of these two vectors. And it's a simpler way, and it's that you multiply the x components of each vector, and you multiply the y components of each vector, and you add them together. Now that we know all the pieces of this puzzle, all we have to do is solve for the parts of the puzzle so that only the cosine of the angle between these two vectors is what the only thing that's unknown. So, to find the velocity of the ball relative to car B in each case, we recognize that the velocity of the ball relative to the ground is equivalent to the velocity of the ball relative to car B plus the velocity of the ball of car B, relative to the ground. So let's look at case 1 first. In case 1, we recognize that the velocity of the ball relative to the ground is equal to 8I plus 6J. That was what we found in part A of this problem. We also know, because we solved part B, that the velocity of the ball relative to the ground is equal to minus 6J hat. And so now that we know this, we solve for the velocity of the ball relative to car B in the first case, and that is equivalent to 8I hat plus 12J hat. And now we solve for the second case. This is the part of the problem where it got wrong, because instead of actually carrying out the procedure I did in case I, what I did instead was carelessly assume that the velocity of the ball relative to car B is the same as the velocity of the car B relative to the ground. That is to say that the velocity of the ball relative to car B is simply negative 6j, and that's completely wrong because we're looking for the velocity of the ball relative to car B when Q passes it to P, not the velocity of the car B relative to ground. Okay, so let's solve this the right way. Since we are told in part B that the velocity of the ball relative to the ground is the opposite of what we found in part A, we know that the velocity of the ball relative to the ground in part B is negative 8I minus negative 6j. And of course, the velocity of the ball of car B, relative to the ground will be the same. And so we can solve this equation and find that the velocity of the ball relative to car B in case 2 is negative 8I hat. Now the dot product calls us to find the magnitude of these vectors as well. To find the magnitude of a vector, we just take its norm. So we take the norm of the vector in case I, like so. And we find that it is equal to 14. In case 2, there's only one component we need to worry about, and we know that from studying vectors that the norm of a vector with only one component is basically the absolute value of the magnitude of that component. So we know that the velocity of the ball relative to car B in case 2 is just 8. We also need to solve for dot product using the second method I talked about in this video, so that you can find all the pieces of the puzzle and be able to solve cosine of theta. We already know the x and y components of each vector because it's represented in component form, as shown here. So we carry out the formula like so. And we find that it's equal to negative 64. Cool, so now we know the magnitudes of each vector as well as the dot product of the vectors. So now we just plug in and find cosine of theta. (14 times 8 is equal to 112. And to find cosine of theta, we would divide negative 64 by 112, and you need to use a calculator to find the decimal value of this. But since I don't have a calculator handy with me, I'm just going to express it as a fraction. You can do the rest whenever you want, but just know that to find the cosine of this angle, we would have to divide negative 64 by 112. And this is the final answer to part C. Thank you for watching and have a good day.